Bismillahirrahmanirrahim. Dear students, we are going to discuss today antibiotics. What actually antibiotics are? The chemical substances produced wholly or partially by chemical synthesis. They can be produced or they can be generated. They can be synthesized. We can say artificially by humans, or we can say by scientists, which in low concentration inhibit the growth or destroy microorganisms by intervening there, we can say, metabolic processes. So these are those actually drugs, those substances which are generally partially or wholly and solely synthesized, or we can say chemical synthesis, and hence they inhibit, or we can say they stop the growth, or we can say kill, or we can say destroy the other microorganisms. The first breakthrough was the discovery of penicillin by Alexander Fleming in 1929 from Penicillium notatum, we can say a fungus called as Penicillium notatum. When Alexander Fleming found an antibiotic which was produced by this fungus in order to inhibit the growth of other bacteria, or we can say other microorganisms, was really a great real revolution. However, with the passage of time, different types of antibiotics was synthesized. We can say antibiotics can have either cidal, we can say, effect, killing effect, or we can say static effect, that is we can say inhibitory effect on microorganisms. So antibiotics have two types. One is called as bactericidal, another one is called as bacteriostatic. Bactericidal antibiotics are, we can say, penicillin, ofloxacin. Similarly, bacteriostatics are erythromycin, tetracycline, or we can say chloroamphenicol. So another classification of these antibiotics can be on the basis of their we can say effect, their effect of we can say inhibition, their effect of inhibition. First one is called as broad spectrum, we can say antibiotics. These are those antibiotics which kill or inhibit a wide range of, we can say, gram positive and gram negative bacteria, like we can say ampicillin, amoxicillin. These are the two main antibiotics which have a broad spectrum and which are used as broad spectrum antibiotics. Similarly, we have narrow spectrum antibiotics. They are those antibiotics which are effective mainly against gram positive or gram negative bacteria, like penicillin G. Similarly, we have limited spectrum, we can say, antibiotics. These are those antibiotics which are effective against a single organism, or we can say disease. So another breakthroughs are, we have chloroamphenicol. 1947 was discovered this type of, we can say, isolated this type of antibiotic. It is a broad spectrum antibiotic. The main we can say disease which can be cured or prevented by chloroamphenicol are typhoid, dysentery, acute fever, meningitis, or we can say pneumonia. Another type of, we can say, another examples of antibiotics are, we have vancomycin or ufloxacin are also important toxic, we can this sorry broad spectrum antibiotics, very important. So many antibiotics are we can say can be synthesized, or we can say can be isolated from different microorganisms in order to inhibit the growth of others, or we can say that is what we call this. Since one organism produces the antibiotic in order to we can say inhibit or grow the other organism in order to make the survival for fittest, according to Darwin's theory of evolution, right? To make itself survival for fittest, or we can say there is a competition for food, right? So these are the examples, general examples, like this is what we call as penicillin, a sulfur containing compound here, sulfur nitrogen containing compound. This is the structure what we have. Here we have here amide bond, here we have carboxylic acid, here we have sulfur atom, here nitrogen. So many functionalities in this are called as penicillin. Similarly, we have chloroamphenicol here, nitro, it is also containing so many, we can say, this functionalities, like hydroxyl groups are there, alcoholic groups, ketonic groups, chlorine, or we can say nitro groups, or even benzene ring is there. So this is chloroamphenicol, very important antibiotic which is very important in day-to-day life. Similarly, another medicine that is called as antacids. Antacids are generally those medicines which are used to neutralize the stomach acid in we can see in order to prevent burns, or we can say ulcerations in the stomach. So the excess of HCl, since the HCl is released in our stomach, so the excess of HCl can cause burns, or we can say ulceration in the stomach. So we use such a medicine so that neutralize this acid, that is hydrochloric acid. In order to neutralize this acid, hence that antacids are generally basic in nature. They are base and hence are used to neutralize the concentration of acid, right? So when a large amount of acids are produced in the stomach, the we can say the natural mucus barrier that is inside, that is in the stomach, protects the lining of the stomach gets damaged. The lining, which is called as mucus, we can say mucus lining, the natural mucus barrier that protects the stomach, it gets damaged by the excess amounts of HCl which is released there. Hence this damage on we can say this mucus barrier can cause burns, or we can say ulcerations. So there, because of this huge amount of acid with the acid reflux, right? So there are some we can say bases like magnesium hydroxide, that is MgOH2. Similarly, we have aluminum hydroxide, AlOH3. They are generally used as general bases which are used to neutralize the HCl in the stomach. The side effects are there also with the antacids like constipation, diarrhea, osteoporosis, and kidney stones can be formed because of the excess amounts of antacids. So these are the side effects which can be caused by using antacids. So in this way, the two medicines, antibiotics, antacids, are discussed today. Hence, hope you understand today's topic. Thanks for watching.